In this video, I will be analyzing in depth the infographic I made covering film photography. In this infographic, I introduce how film photography works, the development process, the history of film, and a look into the film industry. My goal from this infographic is to inform viewers about how film photography works and how it has affected the photography world we live in today. Through different displays, I explore the visual potential in each piece of information on film photography. I would also like to introduce the models I used to base my infographic off of. Throughout this video, I will be explaining how these models were emulated. For the layout and visual model, I used this infographic. For the color model, I used this infographic. Now we will begin to analyze the displays made in the infographic. First, I would like to explore the 5 forms of visual potential. Visual potential is the potential of information to be communicated in graphic form. In other words, visualizing information makes it more relatable to viewers so that the information is more easily understood right off the bat. I'll start off by introducing the visual potential of appearance. The primary appearance display found on my infographic is the image found down the middle. I exploited the appearance potential in my appearance display by designing a camera and a film strip. Appearance displays are used to draw the reader in and present the infographic's topic at a glance, and also provide what the topic might look like. I also included the topic's title and description, which fits into the goal of an appearance display, to show what the infographic is about. These 2 features help to provide context for the viewer so they can immediately grasp what they are viewing. From the visual and typography model, we can see the similar elements used. On the left, the model introduces the topic with a large title, subtitle, and body text. This setup is clearly emulated in the appearance display, created with the stark background to draw the viewers to this title. On the right, we can see that the model uses simple shapes with fill and shading to represent the topic or something related to the topic. The appearance display emulates the model with the use of simple shapes, minimal detail, and rounded edges to convey to the viewer that the infographic is about film photography. Some slight departures from the model occur with some straighter edges and smaller lines to show some detail. However, with the color model, there are not many colors to choose from to make the details through shading. Therefore, in order to show some detail, little outlines were necessary. While the previous display was the original appearance display, there were also other components that drew on appearance's visual potential. First, in the bar graph, film strips were used to show data. This follows the model's use of simple graphics to visualize data throughout the model. Next, appearance displays were used throughout the relationship display in pieces to associate the step of the film process with an icon or simple image. This helps the viewer immediately visualize this part of the film development process. Next, I will be exploring the visual potential of relationships. The visual potential of relationships is the potential to convey links between concepts. I exploited relationship potential by showing the steps in the film development process. The different parts shown highlight the relationship between all of the elements in developing film. This display shows the steps connected by lines to indicate that one state follows from the previous state and leads to the following state. In this display, I showed a series of steps that take an undeveloped piece of film and develop it. As shown earlier in the appearance visual potential, each step includes a simple icon representing what happens in the step, a number in the process, and the description underneath. In addition, the subtitle above some steps describes where this takes place. While the relationship diagram is not specifically modeled off of any particular piece in the visual language model, it does draw off many elements found on the model. First, it uses a faint dotted line that is also found on the model. The appearance display emulates the model with a simple icon in a circle. From the visual model, the display uses the model's numbers surrounded in circles. Lastly, one can see the similarities from the color model. The model has only white text on the dark background, and light blue is used most prominently. Black is used as a fill, and black text is found on the light blue background. All of these rules are followed in the relationship display. Next, I will go over the visual potential of numbers. Exploiting visual potential of numbers means showing the size or amount of something through encoding differences visually. For this potential, I used a bar graph to show the differences between profits. The length or height of the bar graph correlates to an amount of profit. The taller the bar is on the graph or plane, the greater the profit is. In addition, this form of visual potential draws off of encoding colors to show the differences between the two companies. Through the height and color encodings, one can see the trend that each company takes over the years. As mentioned earlier, this display uses film strips as a form of appearance potential as well, just like the visual language model uses to display data in bar graph form. The visual potential of time conveys the relativity of time between events through the relative position of the event. By highlighting specific events in a timeline, one can see how things have changed over time. I exploited the visual potential in my film photography timeline by showing how film became popular. Through this, I selected different important events of film inventions through time and showed them linearly through a timeline. Again, drawing off of the use of simple appearance displays, each timeline event is denoted with a film strip, which encases the bolded year. Then, the viewer reads the orange title and the description of the event. The timeline uses dotted lines with larger white dots to denote the event. The year is prominently labeled so that users can follow the timeline of events. The title in orange is used to convey how this event affected the popularity of film. I would like to note that while all of these elements built off of the visual language model, there is a slight departure from the color model with the use of orange text. While the model only uses white text, this departure was necessary to show a difference between the title and body text. Since the title and body text are close in proximity, I felt that even with different weights in the font, there should be a clear difference so viewers can clearly and quickly read over the titles at a glance. The visual potential of location is the ability for viewers to associate shapes with a real place. Location displays show you where something is visually. I exploited location potential through a camera's light path. On the left, you can see a cutout display of a film camera. Different parts of the inside of the camera are labeled with a highlighted path of the light. This shows where the light enters and exits in the camera and the points it hits as it moves through the camera before hitting the viewfinder or lens. Thus, through this display, users can see where light travels through the camera. While there is no similar location display used in the visual language model, different parts are used in the display that emulate the model. For example, the dotted lines used the numbers, labels, and circles. Again, there is a slight departure from the color model with the use of orange text. However, I felt it was necessary to label the line with the same orange color, so it is more apparent that these labels go with the line. In addition, the proximity of the label light exits is too close to the viewfinder label. This difference should be apparent, as it highlights the path of light and not just a specific labeled element. To further support this departure, I would like to point out that labeling the line in the same color as the line helps to associate and is an established convention to the infographic, with the timeline labels being orange as well. Now I'll be moving on to analyze the encoding used in my infographic. Encoding is an important part when visualizing information. This refers to translating information into a visual attribute. There are many different ways to encode information. Encodings include color, shape, position, interaction, line treatment, and size. In my main appearance displays that were introduced earlier, no major encoding was used as there were no points of data to visualize. However, throughout the infographic, many simple graphics are used with encodings. For example, in my numbers display, simple appearance displays were used to represent data. The film strip length was used to show the amount of profit the film company was making in that specific year. Thus, the position of where the film strip ended was the encoding for representing how much profit. This information is also encoded by the size of the film strip. The color of the film strip is also encoded information as it shows to the viewer which company the data is revealed. Similarly, the visual language model encoded information in the same fashion, with use of color and length or size of the bar in the syringe. These encodings are intuitive to the viewer because they follow the conventions set by bar graphs. They are aligned in space, so the position of the end of the bar and the size of the bar tells us how much that year's profits were in comparison to the other years. Another encoding that could have been used might have been a line graph or encoding with position, which loses the size encoding that the bar graph gives us. The line graph could have been used because the same idea would have come across in the trends over time. However, the lines used in the visual language model were only straight 90 degrees, so this would have been a major departure. There's a small departure from the visual language model currently, with the bar graph created as the model only gives horizontal bars. However, because I wanted to highlight the differences over time and fit into a limited space in the layout, I felt it made more sense to keep them vertical. The model also does not need to show trends over time with their bar graphs, so it is more necessary to show this data in a vertical size. Another example of encoding can be found in my relationship display. The relationship display outlines the steps in the film development process. The encoding when showing these steps is the position of each step. I use the English language convention of reading left to right so readers would see the position of each step in relation to one another. Also, the position of some of these elements are closer than others, which forms clusters of the steps. The clusters associate as all falling in the same location of where these steps take place. For example, steps 1 and 2 take place inside the camera. The clusters were originally denoted by the color of a larger box surrounding the steps. However, after many revisions of the relationship display, I found that this could be accomplished without the filled blocks. In addition, this display seemed to stick out in the final layout of the infographic, as other displays did not use this fill technique. Lastly, the filled boxes did not seem to follow the elements found in the visual model. Similarly, in my time display, I encoded information from left to right in position so that the viewer would read the events from left to right in time. This encoding was used because the information was listed chronologically. In this way, viewers could see relatively what events happened before others. For information displayed chronologically, position that goes from left to right makes the most sense for a timeline. However, this information could be changed to be displayed vertically, starting with oldest events and going to the most recent events at the bottom. With space constraints on the layout model, I kept the orientation horizontal. Lastly, I spaced the events out to be the same distance instead of a traditional timeline that spaces out distance depending on time between events. I did not change distances because there would be spacing problems in the display, as well as the lines used in the visual language model were only 0 or 90 degrees. Thus, the timeline was kept more relative. Now I will move to analyzing color used in my infographic versus the color model. The color model used approximately 4 main colors. They include a light blue, dark teal, rust orange, and black. White is also used just for text throughout. From the analysis of these colors, we can see that the colors together represent a split complementary color harmony. The black is a neutral color and does not affect the color harmony. The dark teal background combined with the use of light teal creates an informative, serious tone. The use of the dark orange color complements the teal and captures the reader's eyes. These colors pair nicely to captivate and interest viewers. These colors are not encoded for one specific piece of information throughout the model. However, they are assigned to different displays and represent different pieces of information. Similarly, in the visual displays created in my infographic, we can see that color is encoded specifically in the numbers display. There is no real association attempt when working with these colors, as the topic is somewhat unknown and not associated with colors. Thus, these colors and topics do not associate for many people. Color is not used to highlight in the color model. Dark orange is the color that pops out the most, but it is used just like the other colors, so it does not seem to highlight any specific part of the infographic. When designing my infographic, the largest concern with following the color model came with the different amounts of color used. I paid very close attention to the small use of orange. While there were many different patterns found on the color model, I found that the visual language model used simple fill shapes. Therefore, I felt that introducing patterns would be a departure from the visual language model. Next, I will analyze the typography of my infographic. The two fonts I identified from the typography model and used throughout my infographic are DIN Condensed Bold, found on the left, and DIN Alternate Bold, found on the right. The primary differences between these fonts is that the DIN Condensed Bold has horizontal terminations, whereas the Alternate Bold has diagonal terminations, and DIN Condensed Bold has skinnier letters than the DIN Alternate Bold. In the title of the visual language model, the font is capitalized, the word is bold, and the letters are skinny. All of these characteristics match the DIN Condensed Bold font. Both precision labels and identity labels are used in the model and final infographic. Precision labels are primarily used because of the nature of the data. Because identity labels specify what a graphic element represents, this is not as necessary for the displays created in my final infographic. The labels in the key for the numbers display could be changed to identity labels. However, the key in the visual model does not use a different font when compared to the identity labels. Body text is used in a minor amount of elements in the model, so I added some descriptions for the location and numbers display. I added a little more text for the location display. However, I feel that this is a necessary departure as the text helps viewers understand what the graphic means. Furthermore, the model uses more text in describing the pieces of data, so I'm just matching the amount of detail. For all of the labels found in the model and my infographic, they are associated with the object based on proximity. However, the model makes use of little flags used as leader lines with identity labels. I do not use a large amount of data categories in my infographic, so I did not need to use these flags or leader lines. Next, I will be discussing the visual language of my infographic. Looking at the visual language model, I will show the elements incorporated into my own infographic. First, the faint dotted lines used in the model were incorporated into my infographic with the use of the rust orange. While the model's lines colors are much fainter or lighter, I felt that using the color model's orange was necessary for the lines used in my infographic because more lines were necessary in the data. When looking at the model's information, no lines are used in the actual data displays. Since I created a timeline, relationship display, and location display that all needed lines, I felt that the line should be more emphasized in some places. I did also use the light blue colored lines to differentiate the lines when necessary. The visual model uses simple fills in its shapes with no texture. Shapes are almost always rounded on the corners. All of these characteristics were taken into account on my infographic. Abstract and simple shapes were used to create real objects. These simple visual concepts were used when creating my own graphic elements. For example, I created round, simple, build, film strips, and simple icons. Visual hierarchy refers to variation in visual prominence of elements in a display. The visual hierarchy of elements guides attention, conveys importance, and creates interest. I created my visual hierarchy in the infographic overall by following the layout model that separates the model into two different main sections. With this layout, the viewer is guided to the first large title and large appearance display in the center. Therefore, the visual hierarchy is established by the size of these two elements. Then the viewer is drawn to the title because of the size of the font and the drastic contrast between the light white font and dark black background. The visual hierarchy is established because of the appearance display that acts as a divider. They should then follow down the left column of the display and view both sections. Then view the other column starting at the top and moving down. Overall, this spacing and use of appearance display separate the elements to create a visual hierarchy that leads viewers through the information. In addition, the sections are clearly marked with the same banners throughout, so the viewer can see each of these displays. In terms of each display, viewers should generally follow each display down from the title, read the subtitle and description, and then look at the visualization. If there is a line, in the case of the relationship and time displays, the information flows from left to right so readers can glance over the information. Taking a deeper look into the displays, we can see how visual hierarchy is established in the location display. The two sections found under the title are separated with the visual language model convention of the dotted line down the center and under the subtitles. The viewer would be guided to look at the display on the left first, as English follows this convention. Ideally, the viewer would read through the description and be guided with the labels mentioned in the text to look at the model's labels. However, if a viewer did not read the first paragraph, they might see the labels and then go to the paragraph for more context. The use of the highlighted numbers should helpfully guide users in understanding this visualization. In addition, the takeaway I want users to understand from the location display is that the light moves in a specific path. This is a prominent piece of the display because it is highlighted in the rust orange color while the rest is not as prominent. This color creates the visual hierarchy along with the all caps text. The numbers display uses the same visual hierarchy, which is established through a prominent highlighted title, lighter body text, and an all caps subtitle with the only rust orange element in this display. Proximity and spacing are also help to define where the user should look. As they go down in elements, they should see that the bar graph is described by the title and the key is also related to this bar graph. In the time display, the viewer should see the title first with the highlighted and all caps title, then see the large prominent years. These are the most important piece of information and help the viewer to understand that this is a timeline. In addition, the contrast of the white text on the black film background make them stick out more and thus higher in the visual hierarchy. Because the timeline is shown on a line, the information is read left to right for English readers. After reading the number of the year, they are drawn to the title because of the different color and its proximity to the year. Then the description text is read last because it has the smallest weight as text and is below the prominent years and titles. The relationship display's visual hierarchy is similar to the timeline, with the line telling viewers to read left to right. In this display, they are drawn to the numbers and see the icons to get a brief overview of the display. Then they read the label describing the steps. The spacing icons and numbers help to differentiate between these steps and guide the user through the display. These elements help to create the visual hierarchy. Unity and variety across the infographic helps the viewer easily view an infographic with lots of information instead of getting overwhelmed or bored from the visual. The element of unity is achieved when the different components of a design complement one another rather than compete for attention. When elements are repeated across all components, it helps to create unity. Variety is also needed as well. If too many similar elements are repeated, it seems boring to viewers. Looking at the final infographic, we can analyze the elements of unity and variety found throughout. In all 5 visual potential displays, there is a graphic element of film. In addition, dotted rust orange lines are used in each display. The banner titles are used to introduce each of the sections and divide the display. Numbers and circles are used in many displays. There is a good amount of variety throughout the infographic in each of the displays because the information is all very different and displayed in different formats. The timeline and location display are somewhat similar with their structure, however, the elements are different. The location display is paired with another appearance that uses a fill, whereas the bar graph introduces film strips as data. While the variety and information visualizations is quite different, the underlying structure of each of these sections is the same. Therefore, the unity and variety between these elements pairs well. Comparing the visual language model to the infographic, we can analyze the differences and similarities in unity and variety. In the model, data is presented in very different elements, but all with the same color. This is somewhat of a departure in my infographic, as the data does not have a specific color. However, the model almost exclusively shows number displays, so it does not make much sense for the different displays made in my infographic. The model is emulated with the use of banners across all of the sections. In addition, the subtitles, body text, keys, and the spacing between all of these elements is matched in the infographic. Next, I'll be analyzing the layout of the infographic and how it matches the layout model. As mentioned earlier, the flow of the infographic is established with the layout of the sections. The introduction of the appearance display in the middle of the infographic creates a 2-column flow. The first 2 sections are read after reading the title and viewing the appearance display, then the other side of the appearance display is viewed. All of the sections are grouped with the light blue banner placed at the top of the section. The proper spacing is applied to each of these displays. I also took into account the content found in each display. I felt that how the camera works and how the development process works should be placed before the other displays. This is more vital, important information. Therefore, some changes were made to the original layout. The layout is closely followed with 4 main sections and divided in half with the appearance display and a large title found in the top. However, the exact sizing of these sections is different in the infographic. As I described on the previous slide, I found that the information should be presented with the location and relationship displays presented first. In order to make this change, I found that these 2 sections needed more horizontal space, whereas the other 2 displays on the second column did not need as much space as what was first established. In the layout, the appearance display cuts the space more closely on the first column and lots of space is left for the second column. Therefore, I changed the appearance display to be closer to the center to allow for this information to have the correct spacing. Again, the layout model has many similar displays with not as much variety in the information visualized, so more spacing is necessary for some of my elements due to the visualizations. Finally, I will analyze the alignment found in my infographic and the layout model. Alignment helps tie elements together into a group, as well as do the opposite to separate elements. Elements are aligned on the left-hand side of the infographic as they are all left aligned with the same margin. However, the banners go off the page to make separate sections. Similarly, on the other column, the subtitles are aligned and the text is aligned with where the title text begins. However, information surrounds and fills the space around the camera, so similar distances are found around the camera. All the data elements found in each of the displays are grouped together in their own standard way. For example, the labels in the location display are grouped together with the same distances. The relationship display has each step grouped together with the same spacing. The time display has specific spacing for all of the elements found in each event. The numbers display groups the years and the two company profit bars together with the labels. All of these years are lined at the bottom with the same spacing between years and profit labels. All of the sections have information spaced out the same amount between subtitles, body text, and information visualization. Similar alignment is found in the layout display. There is a common margin and padding around the appearance display. There is a clear text line along the left side, which was mentioned previously in my infographic. In addition, the titles on the right column are also aligned. One departure from the model is that the sources are switched sides with the author. This was done because the display found on the bottom left of my infographic is very text heavy, so the source's text felt very unbalanced to the original side. Thank you for watching, and I hope you enjoyed this in-depth analysis of my infographic.